Hello everybody, welcome to this session, Cloud 101, and this is where every cloud application starts. My name is Satish Vijay, I'm a developer expert on Google Cloud. I also run this channel called Awesome GCP on YouTube, where I help people learn and understand Google Cloud and also prepare for the certifications. What I'm going to walk you through today is to understand what is the cloud, what are the core components, and what is the hierarchy that builds up. So we're going to take a bottom-up approach where we look at each of the core components and build that up into the larger pieces. Then once we reach there, we're going to work our way back down with actual examples. We're going to do a demo so that we go through this process of understanding how it starts from the bottom up and then come down, setting all of those that required infrastructure so that we can put out a basic app. In doing that, we also need to take care of security. And today we're going to focus a little bit on network security. Having all that in place, the next step is to build our app and then have that be accessed from different places. Working with the cloud, of course, you also don't want runaway costs for the resources that you provision and use. So we'll also see how we can investigate these costs. Now, the first place to start with is to understand what is the cloud itself. And what are you doing on the cloud? Essentially, what you're doing on the cloud is to do some kind of computing, some kind of processing, some kind of calculation. So every time there is an input that is coming in, we want to process it in some way and then send it out to some kind of output. These inputs are usually in some persistent storage, like a hard disk. So you take it from the storage, you bring it into memory such that the CPU can then access that memory and do the calculation. That processing. It need not be just mathematical calculation, of course. It could also be, say, working with a database or helping somebody do a transaction online. All of those processing and transactions and calculations are done in memory and in the CPU. Once that is done, this can of course be sent back to the user or also can be put back into storage. So a computing unit has to have an input. It has to have some kind of processing and output, and that is the essential computer. So when we look at the cloud, we have to consider it from two angles, or rather two layers. One, there is the physical layer, the hardware, the wires that actually connect all these things together. And then above that, there is an abstraction. There is a logical layer where some of this hardware is sliced and diced in different ways to give you a different representation of what is underneath. So for the most part, in certain kind of services, you don't need to consider the underlying hardware. Say, for example, in the case of what is called serverless or managed services. But what we will do today is to understand from the core components and therefore how it is used, how you can build your own, and also to understand how it is going to be priced. So in the physical view, as I mentioned, the cloud starts with the computer, right? It is said that the cloud is essentially somebody else's computer that you're renting for a while. And what does that require? It requires for the processing, input, output, and processing, it requires that there be some processing unit, the CPU. It requires that there be some kind of persistent storage, right? So the input and the output could come from, say, old historic data, or data that just arrived yesterday that you need to process. Maybe if you're looking at, say, your Gmail, right? The Gmail is stored somewhere, so you need some kind of storage. And when the CPU is doing processing, it doesn't directly access it from the storage. Instead, it has to be brought into an intermediate storage, which is the RAM, the random access memory, which is much faster than the storage like a hard disk. Since these computers are somewhere else, you also need to have a way in which you connect to them, right? So a network is essential. When you're working at home on your own computer, you don't have this problem, right? You could isolate yourself from the network and just work on your computer alone because everything you need is there. However, in the case of a cloud, because these are computers somewhere else, you have to have a network also. So where are all these computers? Google has purchased all these computers and kept them ready for you to pick up and rent as and when you want. So this is one view of one lane in a data center where in these racks that you see on either side, there are many computers. Those racks is what you see over here as these lines over. All of this is in a building. It has got multiple sources of power. And this whole setup, one building with all these racks and its own individual power sources, that is called a zone. Usually there are multiple zones that are together, right? In the case of Google Cloud, almost every one of these groups have 3 zones. And a collection of zones is called a region. There is one region that has got 4, but all the others have got 3. So this allows for redundancy in a local region, right? The alternate way is to have multiple regions, and you have these redundancy that you want. Say if one system goes down or one area is affected by, say, a power outage or a flood or a political reason, you can always move your workload to another region. And these regions are going to be at least 100 miles apart. So a collection of zones make up a region, and the region is more of a logical concept, right? And what we see is these buildings and all that, which is what we refer to as a data center. And it is kind of something that you could use one term or the other to refer to this group of buildings that is serving you these machines, these virtual machines that you can rent out. These regions are spread across the world. Today there are 24 regions in various continents that Google operates. And as I said, each of these have at least 3 zones, which is why you've got 24 into 3, 72, and there's plus 1 in Iowa, which has got 4 zones. And these reach out to people across the world, and they're usually centered around places where there's a lot of people, right? So you want, when there's a large load of people, like you have cell towers today, right? In places where there's a large group of people, you're going to have more of these cell towers. Similarly, you typically have these regions where there's a lot of users who are coming in to use that. Google has also announced 9 new regions, which should make it the largest cloud provider in terms of the number of data centers. With all these regions spread apart, you also need to have a way for them to talk to each other. And this happens all over a very fast network that connects multiple parts of the world. Google today boasts of the most number of kilometers of network that it owns. There is undersea cables and terrestrial cables that crisscross the world, connecting all these different places and these data centers, which make sure that when you have to use, say, some service like, say, Gmail or YouTube, you're potentially going to the nearest data center, right? Because data that has to travel far distances take more time, and that increases latency. So ideally, you want to serve your users very quickly and very fast, which means you choose a data center close to where they're likely to be. So let's look at this hardware now, okay? And what are the different terms we have when working with this? A virtual machine is an abstraction of a part of a hardware machine. So you will have the CPU and the hard disk, but there is a way in which you can abstract that and make it look like there are, say, probably 2 or 3 machines that are being served by the same underlying hardware. And Google manages that for you, right? And it is possible that even the same machine is shared by 2 entirely different people, like 2 entirely different companies. But there is a clear separation between them that is managed by all the amazing software that ensures the separation of these entities. So this virtual machine that you saw is going to be in a zone, and that zone is going to be in a region. Of course, in a zone there are going to be multiple virtual machines, and in a region there can be multiple zones. We saw that typically there are 3, and of course there are many of these regions spread across the world. So now we've got a physical view of what is provided to you. Let's look at now a logical view. The starting point for us is to visualize where these computers are. As you saw in the earlier picture, on a single rack, you could have many computers that are available for you to rent. Right? So let us say this is just one section of that, and all the gray ones are still unused. A person, Mr. Blue, he comes in and says, you know what, I need 3 virtual machines. Google Cloud will then pick up 3 virtual machines that are currently available and allocate it to that person. Then say Mr. Red comes in and says, I want 2 virtual machines. Again, Google Cloud goes in and says which one of the machines are free and allocate 2 of them and provide it to Mr. Red. Now we need to have a way in which to ensure that Mr. Blue and Mr. Red, they don't have their workloads colliding with each other, right? Mr. Red shouldn't be able to access anything that is allocated to Mr. Blue and vice versa. So there should be a clear separation between them at a logical level, even if at the physical level they are very close to each other. The way you do that is you have a network. So again, going bottom up, a subnetwork is part of a bigger network. And in the diagram that we had earlier, our subnetwork is going to span a region. Now, when you work with certain other cloud providers, their subnetwork might be in a zone, but in the case of Google, Cloud, a subnetwork is going to span a region. So you don't need to create separate subnetworks for each of the zones. A single subnetwork is enough for one region. And there are going to be multiple such subnets that you can have in a region, and at least one subnet is typical. If there is a region that you're using, you will have a subnet over there. The subnet itself builds up into what is called the VPC network or the virtual private cloud. So think of it this way. There is the physical cloud, right, which is all the hardware, all the machines and the racks and the zones and the regions, the data center itself. You are getting a part of it carved out for you, right? So in the earlier example, Mr. Blue and Mr. Red, they are in completely different networks. A logical view that separates each of them with no automatic access between them, but if they choose, they can of course have access, but by default they do not have access even if these machines are right next to each other. Even if you're sharing the same CPU, a person who owns one network and a VM within that is completely different from a person who owns another network and has a VM in that. So, and all of this done with a software layer that logically separates these machines. Within a VPC network itself, you usually start off with having all access open within the subnet. This is normal, right? You want to keep it open. You don't have to, but typically you allow all machines, all virtual machines within there to access each other. You can also ensure that other machines, other virtual machines sitting in another part of the VPC network is also accessible. You could restrict access, but typically you tend to keep it such that your VPC network is isolated from everybody else, but within your VPC network you have enough access going around to get your task done. So as I mentioned, these two separate VPC networks, even though they're in the same project, they start off being completely isolated, right? These have no way of directly communicating, and even when we are doing the example later on, instead of creating multiple projects for the sake of simplicity, I'm going to work with two networks in the same project with the knowledge that they start off being completely isolated. So typically machines within this VPC network can access each other, but across them they cannot be accessed. With that in place, now let's start creating a cloud application. What do we want in our cloud application? What we want is, we want to set up a virtual machine in each of these networks, what we'll call default and custom, and we'll see what those are soon. We will create a small web application called Hello World, and we want to be able to access it from an outside computer. So the machine that I'm working from, I want to be able to set up a web application that I've written and access it from anywhere. And of course, you should also be able to access it from each other. So our first demo takes us to the default network. When you create any project, by default, it creates a certain network for you. So if you go to the hamburger menu on the top, choose VPC networks, and then VPC network, you will see that by default there is a network called default, which is of type auto. This is an auto mode network, and but it is given the name default. An interesting thing to notice about the default network is that it has automatically created subnets for you in all the regions that are currently available. So just to pick two of these as an example, right? So there is a region in Mumbai, which is Asia South 1. There's a region in Sydney, which is Australia Southeast 1. So on for each of the others that are these regions that are currently available, all of them have an automatic subnet created for you. So this creates certain defaults that allow you to work very quickly with these networks. So you don't need to set it up. As soon as you start a project, you can start creating virtual machines as you want and work with them. What we are going to do next is we're going to create a custom network. Okay. The way you create a custom network is like this. So you go to VPC networks, you say create VPC network, and I'm going to create the my custom net. We can go down to creating a subnet. Let us call it my subnet. We have to choose a region for it. For our example, let us say we chose US Central 1. And we also need to choose a IP address range. So in the earlier case, these IP addresses for the default network are automatically created for you. But when you create a custom network, nothing is created for you. So you need to create your own subnet. So let us choose something. Let's say we're going to allocate the addresses 10.130.0.0/24, which will give us a few IP addresses to work with. And that's all we need to create a custom net. So at this point, we can see that our custom net has been created, and so also a subnet with the IP address that we chose. So unlike the other one, which has got a default set of IP address allocated, we have complete control over how we allocate these IP addresses and which ones to allocate. So at this point, we now have a default network and a custom network, and even though they're in the same project, they really are not accessible, right? And we've got, this is my computer that I'm working from. Now, the next thing we should do is to create a virtual machine, right? So only the network is there, and we have not allocated any virtual machines, right? So there are all these computers ready for us that we can just rent out as we choose. The question now is, where do we want to create it? What kind of machines do we want to create? What we are going to do is, in the first example, we are going to create a virtual machine using the Cloud Shell. The Cloud Shell is a terminal provided to you to your account when accessing Google Cloud Platform, so that if you are comfortable with the command line, if you are faster with the command line, you can run command line options rather than clicking in the UI and creating your working with your resources. The alternative would be, of course, you can always work on your own terminal, right? You can go onto iTerm or your terminal or your DOS prompt and say connect to this particular project, give it permissions, and then start to work with it. But this is much easier. This is automatically provisioned for you, and you can just start using commands there. So let's do that for our project. So you go to the Cloud Shell. So at this point, we have got our Cloud Shell ready. It's given me an account, and I know which project this is a part of. To create a virtual machine using the command line, there is a command that you can issue, right? So the way to do that would be gcloud compute, because this is a compute instance that we're going to create. It is in the general category of compute, and now we are trying to work with instances. So we are saying gcloud compute instances. What do we want to do? We want to create an instance. The name we will give is VM in default net. Okay, so that's the name for the VM that is going to use. Where do we want to create it? Given that we created a network, a subnet in Central 1, US Central 1, we are going to create our machine in a zone within that region, right? So the region itself, the subnet spans the region, and we can create in any of these zones. So if US Central 1 is the region, then US Central 1A, 1B, 1C would be each of the zones. These are not fixed. They can be, they might sometimes miss out an A or do a B, C, D for whatever reason. So check what the zones are. You also want to indicate what kind of machine that you want provisioned for you. So I'm choosing in this case a N1 standard one machine. And because we have different networks, we also need to indicate which network we want this in, right? So this is going to be the default network. So we have issued that command. Let's authorize that. And while that is in progress, we can go check if it is getting provision. Where would that be? It would be under Compute Engine and VM instances. Okay, so it has given us some indication that it has created the machine with these details, right? As we asked for, it is going to be in US Central 1A. It is going to have the name we required, and we've got a certain machine shape or machine type. It has also given us an internal IP such that it can be accessed within the network, and also an external IP with which we can access outside the network. It is currently running as we can see. So if we want to directly access the machine itself, one of the ways to do that is to click the SSH button, which will give us a terminal in the browser itself that allows you to run commands on that virtual machine. As we can see, now we've got our machine and we can access that machine. So there's nothing actually on this machine right now, but we can see that this is logged into VM in default net. So that is the name we get. So there is a direct way in which you can access your virtual machines from the browser itself, which is very convenient. All right, so let's close that for now and let us look at the next part. So the next thing we should do is to check whether we can reach this virtual machine, right? Is it possible to reach this virtual machine? Okay, let's try that. How do we reach that from an external endpoint? We should ping it. So let us ping the machine at that IP address and say it is reachable. Okay, so since the Cloud Shell is within the Google Cloud Platform itself, we are seeing that it is able to access that. Let us also try it from say my machine. So I go into my machine, and let's hide these things that I've kept ready for now. Let's keep the top window over here, or the top window over here to work with the default machine. Okay, so we've got ping and the IP address that was there for this machine. Let us see if we can access it. The answer is yes. So in the default network, there are some defaults that allow you to access this machine fairly easily from everywhere, which is pretty cool. So at this point, we are ready to start working with this machine. We can install what we want and we can run whatever program we want. Okay, that's a good start. We have figured out that the VM is reachable. So what has been done? We have checked both from the Cloud Shell and we've also checked from a terminal, and we can see that since the machine is reachable, if we install some application on it, we should be able to also allow other users to access that application. All right, the next thing to do is to create a custom network. Let's do that. For working with the custom network, what we will do is we will go via the console. So we will not use the, we can of course do this from the terminal also, but to just make it clean and clear, let us do it from the custom. Okay, so how do you create a virtual machine? You go into Compute Engine, you choose VM instances, and you can say create instance. Let us name this similarly as we did with the earlier one itself. Let's call this one a VM in the custom net. Let's call this VM in custom net. So custom net. Let's retain the location as US Central 1 US and the zone as US Central 1A. Remember that even though this is the same region and same zone, these are going to be completely isolated networks that we are going to provision this machine. We did talk about what is a machine shape, right? So it's got so much storage, it's got so much CPU, and it's got so much network. Here is where we can choose the kind of machines that we want. Do we want machines with a different amount of memory, maybe, or different number of CPUs? That is very much possible. You could also choose machines that are more memory optimized or compute optimized. Memory optimized machines will have the ratio of memory to CPU will be larger, whereas in the cases compute optimized, the ratio of CPU to memory will be larger. For our simple example, let's just choose a very simple one. Let's say we take the N1 family of machines, and within that is N1 standard one. When these machines are created, you can also choose to say what operating system you want. By default, it has given me a Debian machine, but we can change that. We can choose other ones like, say, Windows or Ubuntu or Fedora or Red Hat or SQL. Many of these are free, some of these are paid. You can also create your custom base images, custom operating systems with even some pre-installed software as a part of it. When you do that, you also choose how much data, the storage that you want, right? So in our case, 10 GB is fine to start with. You're not going to do a whole lot, but larger machines will require larger amount of disk space. Say, for example, if you're setting up a database, you probably want many terabytes of data. So let's select a machine type that is good for us. Later, we intend to have HTTP traffic. So we want HTTP traffic incoming. Let's just switch that around for now. In the networking section, we need to specify where we need our machine, right? So the default value has chosen the default network, but we can change it to the custom network, which is where we want a machine. And we are also going to say, I need this machine to be accessible from outside, so I need a external IP address. By default, it's ephemeral, which means that every time you start or restart a machine, you're going to get a new IP address. If that doesn't work for you and you want a static IP address, you can choose to have that. Be careful though, because you're going to be paying for that even if you don't use a static IP address once you've allocated it. So we continue with the ephemeral. All the other things we can leave it as it is, and now let's create our machine. Okay, now that a machine has been created, let us check, as we did with the default net, let us see whether we can log into this machine. So we click SSH and wait for it to connect. What you're seeing here is that this VM we are not able to connect to, right? So even though we've created the machine and we are trying to do a remote shell, it is not allowing you to do that, right? Even though it's got an external IP. So this is not enough. Something else needs to happen, or something is being missed. Let's go figure out what that is after closing that, okay? So why did that not work? We tried from the SSH. We could have also done the same thing from the terminal. In fact, let's try that. Let's take the external IP. Let's put that in a ping. We'll use a lower one for the custom net, and we're saying let's try to ping it. And it just says request timed out. So clearly this machine is not reachable. Something is missing over here. What is happening is that when we do this, a custom network by default, and any network actually has what is called a firewall. In the case of the default network also there was a firewall, but there were some firewall ports that were open, some protocols that are open that allowed you to access all the basic things, right? So default network sets some defaults that are convenient to start working with. But when you create your own network, these are not done for you, right? So you need to set it yourself. This indicates that when you're working with Google Cloud and setting up these virtual machines, you have got multiple levels of security, some of which where you have the responsibility of managing. If you work with software as a service, say for example something like Gmail, right? you obviously need to take care of your own access policies and content, right? You should not be putting a weak password in there. And all the other things are managed by Google for you. Whereas what we are doing now is we are working with infrastructure as a service. We are choosing infrastructure. We're saying, give me this machine, give me that machine. You don't do that when you work with Gmail, right? You don't, when you're accessing Gmail, the first thing you say is not, oh, you know what, run this on an N1 standard machine. You don't do that, right? It is automatically done for you. But when you're managing your own machines, it becomes part of your responsibility to take care of all the things that are in the green section here, including what is called network security, right? So we're not going to go into all of them. Let's just look at network security as one example. Just within network security itself, there are multiple layers and multiple options, right? So this shows the amount of importance given to security within Google Cloud. Security itself percolates every part of the system, and understanding how this works is very important to being safe and secure on the cloud. So let us next do the step of opening that firewall. As we said, the custom network has no defaults. It is not allowing anything. So it is for us now to go set some things to allow us to connect to this network. Cool. Let's go in there. Let's choose our cloud, and the way we can get to firewall is through network and then firewall. As you can see here, the default net already has multiple options or firewalls, firewall options that are set to allow traffic to come in. The My Custom Net Allow HTTP is automatically created for us because we clicked that checkbox saying, hey, you know what, allow HTTP into this, right? But this is clearly not enough. There is something else that is required. So what is that? Let's create a firewall rule and open that. So this, let us call it My Custom Net Allow ICMP, SSH and HTTP. And what we will do is we will open those accordingly. The network we want this to apply to is My Custom Net, and we can let the priority be 1000. What are the target machines to which this applies? So you can specifically choose machines that say these particular firewall rules only apply to these one or two machines, but not the other machine. In our case, just to simplify it, we'll say, you know what, allow all instances in the network to have these properties. The next thing is a source filter, which says one was a target, right? Like what machines can be accessed. Now the other part of the question is which machines can initiate this access. So what are the source machines? We are going to make this very permissive for now and say any machine on the internet can make this. So the way you say this is using a CIDR notation, which is 0000/0, which says any machine on the internet can access it. Within that, what protocols are allowed? Okay. SSH, which is a remote shell, that uses the port number 22. Typically, AT is open as a HTTP port, but in a later example that I have written, I have specifically chosen the port number 8081. So I need to specifically open 8081 if that is where I'm going to serve my application from. The other thing that I want right now is to be able to ping the machine. So to ping the machine, the protocol that you require is ICMP, and that doesn't have a port requirement. So with that now, we create that firewall rule, and that firewall rule, as we said earlier, applies to the custom net. So once that is created, let us now see if we can access our machine anymore. Okay, so there is the compute instances. We already have the IP addresses for what it was, and let's try to ping it. So we try to ping it for my local machine, and it is still not working. So let's give it a moment. All right. I'm wondering if I did something wrong at this point. So the way to check this, ideally that should have worked if I had set it correctly. Let us ping it again from here and see if that will work. 48 is the right one. Okay, so that works, but it is not working from outside. It might have been a little bit of a delay. Oh, wait, hold on. I was trying to ping the wrong one. What was that other number? Cool. I don't know what machine that was. Okay, so I should be able to ping it now, and it works. Okay. All right. So with that done, where are we on our journey? So we have now opened the firewall, we have enabled ping, and we've also enabled the secure shell, and we are able to access that. So if we have enabled the secure shell, we should now be able to also click here and go into that machine. Okay, this is good now. So we have got our machine in the custom net also accessible. So that's great. Okay, so our machine set up, our network is set up. Now what we can do is we can work with our web application. Cool. So let's close this for now, and we'll reopen it when we want. Now both our machines are accessible in the default network and the custom net, and either this way also it will be accessible. The next thing we should do is to write and deploy a small cloud application. All right. So I have already got some part of this application ready. The application is very simple, right? All it does is start a web server using listen and serve at port number 8081. And if a request is received at the root of the URL, it is going to route that request to this function called hello. And in hello, we are going to print a message on the local command line, and we are also going to send back a response to the client. So if it is a curl request or a request from a web browser, we are going to send back saying hello DevFest 2020. Very simple application written in Go. The way you can build this, even though I'm working on a Mac, using Go, it is very easy to cross compile it. So the way I do that is by saying, with the target operating system as Linux, build this and create an executable for me called my web server. With that application locally available, I'm going to upload it into the two virtual machines that we created. So I'm going to keep my default machine on the left, and I'm going to keep my custom machine on the right. So we've got those two, and we'll have that open up. Now that our machines are here, let us now upload the executable. Now this wouldn't be how we normally do this. There are better ways in which we can manage the automatic and secure deployment of applications. But since it's a simple example, let us just go with this. Okay, so at this point, both are virtual machines, the one in the default network, VM in default net, and the VM in custom net, have both received the file that we uploaded. We need to make this into an executable, so let's just make that the executable like this, and let's do the same thing on the other machine also. Okay, so we've done that. At this point, we should be able to start these two. So we'll start one on the default, and we'll start another one on the custom network. Right? So both these servers are now listening. If this is the case and these machines are accessible, we should be able to ping it from any machine. So let's do that now. Let's go back into our command line terminal and try to access that. Okay. So the way we can do this is we can say curl with HTTP, give the port, the IP address, and send in at 8081. So when we do this, it should now reach that machine and give you back a response. So let us see if that will happen. So as you can see now, this does not allow for 8081 to be accessed. Now the question is why? Okay, so as we can see, for the VM in the default net, by default it did not allow HTTP traffic, and therefore let us enable that and save it back. Okay, when you go back to the machine, you can see that now that it also gives you the symbol to indicate, hey, you know what, HTTP, or you can open something there at some browser endpoint. In our case, since we already have something running there, and now that we've enabled 8081, we should be able to access it properly. So let's do that, and we can see that it works. So it's received the request from a machine, and it has also responded with something. Let's do the same thing for the one on the client one, on the custom net also. So we've got that IP address anyway, and we're going to come in here and we're going to say curl HTTP, and it was at port 8081. Okay, perfect. So immediately we got back a response saying hello DevFest 2020. So what we have right now, therefore, is this. We have created a Hello World cloud application. We've deployed it to both these machines, and we've been able to access that from any computer in the world. And this is just one computer. If you tried it from yours also, it would work. Now that we have this app running, we've used all these resources like the CPU and the storage and all of that. The next thing to consider at a core when you're working with the cloud itself is what about the cost? When you work with fixed assets where you buy the computer right at the beginning, you pay the full price, then you don't really bother about how long is it running, right? Whereas in the case of rented resources, say like for example in the cloud, you need to care about how much it is going to cost you, right? You can't have this unnecessarily running away with a huge amount of cost. So the way you can figure out how much using these machines is going to cost is by using the pricing calculator. So let's look at the pricing calculator for Google Cloud. The pricing calculator for Google Cloud allows you to set values for the kind of resources we are likely to use, and then find out the cost on that. So if you're working with, say, instances, I'm going to say I need 3 instances. I need 3 instances that I'm working with. The typical OS, the regular kind of machine class, the general purpose N1 machine is fine. I would like about one 375 GB SSD. That's what I'd like to have. And this is going to run in US Central 1. Maybe I'm not going to run it all hours of the day, maybe just during work hours, and maybe only during the week. So I can give these specifics and say, how much is it going to cost me? So when I add it to the estimate, it will tell me that, hey, you know what, with this kind of a machine shape, this kind of a machine configuration running for this amount of time, you're going to pay approximately $40 per month. Yeah. Even other things, if you want to add additional storage, say for example, I have SSD provision space, I need an extra 100 GB, let's add that to the estimate. If we want to use any specific TPUs, right, which are like a GPU, right, it allows you to do a lot of AI, ML and all of that easily. That costs you a different amount, and you can figure out how much it is going to cost you. When choosing networking, typically data coming in or ingress is free, but egress is charged. So for example, let us say in this case, we're saying I expect to have about 100 gigabytes of data, in which case you can add that to the estimate, right? So with this, if you're talking to your management, if you're trying to budget for how much is going to be used, with this kind of a configuration with some CPU, some storage, some networking, here is the expected cost that we are going to pay per month, right? So this helps you plan and prepare for the bill at the end of the month. So we've seen the pricing calculator, and on an ongoing basis, you can also look at the billing part, the billing section within your Google Cloud Console to figure out how much you are spending. And there are various things you can do in there, including breaking down the cost and see which projects are using a lot of the spend, which resources are using, are they costing more. You can also set budgets and alerts, which is very useful and interesting because it allows you to, on an ongoing basis, be notified of how much of your budget is being used. In this example, small application that I ran for a short time, you can see that I incurred a certain amount of increasing cost for a few months before I shut down this application. So there's a lot of information with respect to ensuring you stay within your budget. Now, what we saw was infrastructure as service, right? You are setting up the machine. You are using, you're saying, I want so much CPU, I want so much storage. Another way to use services within Google Cloud are what are called managed services, right? Google manages all of it for you, and you don't need to bother about setting up individual machines. And this is a service that even you provide. When you create your application and serve it to your customer, they are not going to set up machines. You are, but not them. And what you give them as an effective cost, the same way that Google is going to give you an effective cost for some managed service like BigQuery, is going to be a combination of the things that we learned today, right? So mostly this is going to be a sum or cumulative of the cost for how much CPU allocated, how much storage you have used or you have provisioned and you've allocated for yourself, how much RAM you've provisioned, how much network you're using, what is the amount of data that is going out, and of course, if you're using any particular security tools. Most of the security related tools that are there by default are free, but there could be some that are costed. On top of that, of course, there could be a charge for the software itself that you provide. For example, when you write the software, apart from the cost that Google charges you, you're going to put in the cost of your effort and your profit and pass that on to the customer. But this is essentially how it builds up, right? From the bottom up, starting with CPU and storage and RAM and network, it builds up into what becomes the effective cost. So in a quick recap, what are the core cloud components? When setting up the very basis of all compute, right, which is the input, processing, and output, which includes storage, compute, memory, those become the basics that you always need. And of course, in our particular case, what we did was we just had the boot disk, but usually you want a place for storing data that is persistent, so that even if the machine goes down and comes back up, you need to ensure that the data is still there, right? Say, for example, databases, right? You need that to be always there. And those are typical outside storage, outside the VM, and you choose that separately. And that's, of course, a very important part. Networking is what brings all of these together. And throughout anything that you do, you need to ensure that security is very good. And as part of security, you set access permissions, right? So we gave some access permissions, for example, with respect to which protocol can, which protocol can come through and access a particular machine. Like that, there are a lot of different things in identity and access management, right? Which user can use it? What permissions can they have? And overall, all of this wraps up into the cost. How much are you going to pay? And so we saw a little bit about the cost management itself. So in this session, your learnings have been these things, right? We identified what are the cloud components and the hierarchy they have, going from the bottom up, building up from the core part of the machine to the to zones and regions and data centers. And then there is a logical layer like the networks and the virtual machines, which are abstracted above the actual hardware. We established some network access and a certain level of security. Then, as an example, we created and deployed a cloud application. And for all of this, we investigated the pricing and cost control. So with that, I stop here, but for you, there is more coming up. After this session, there is going to be Cloud 102 and Cloud 201 and 301. The next one's going to be taken by Dharmesh and Shilpa, which is going to take you into the next stage where you've got all these applications or these applications you've created. Now that you've understood the core part, how do you go deploy them at scale? So please do come back for that. That will be an amazing session too. Meanwhile, I'll sign off. My name is Satish Vijay. I'm a developer expert on Google Cloud, and I also have a channel on YouTube called Awesome GCP. Wish you the very best on your cloud journey.